Alright guys, so this video is going to reiterate a little bit more what we were talking about at the end of class today, and also help you with that worksheet that I gave you tonight. So if you watch the video first, then it'll help you with the worksheet tremendously. If you already turned in the worksheet and you watch the video afterwards and you want to fix the stuff on your worksheet, you absolutely can and turn it back in. It's all about learning. So if you need to do that, you are welcome to get that worksheet out and kind of, be checking along the way. Okay. So what we talked about today in class was this idea of two lines and a transversal cutting them. Remember that? And then towards the end of class, we said, well, if the lines are parallel, even more happens, right? Special things happen. So I want to look at that today. So first of all, if the two lines that are cut by the transversal are parallel, and remember, the way that we show on your diagram that they're parallel is with little arrows. So as soon as I do that, it lets my reader know that those two lines, A and B, are parallel to each other. That's a really big deal. So if you don't know they're parallel, you can't do any of this stuff that we're saying over here. So you have to know they're parallel. Okay? Okay. If the lines are parallel, then corresponding angles, we said, are, let's see if we can remember. Let's take a look. Let me label some corresponding angles. Corresponding angles have to be on the same side of the transversal. So one has to be outside and one has to be inside, and they can't be adjacent. So 1 and 2 in my diagram would be corresponding angles. And you can even look at them. When the lines are parallel, these look like the exact same size angle, and it's true. They're congruent. This is true by something called the corresponding angles postulate. So you're going to be using the word CAP for that, corresponding angles postulate. That's how you can say that those two angles are congruent to each other by CAP. Okay, so those are congruent. So like if I knew that was 60 degrees, that would be 60 degrees. All right, alternate interior angles. So alternate interior have to be on opposite sides of the transversal and be on the interior. So like I could put the 3 here, and now you'd have alternate interior. Remember they kind of look like the Z pattern? So they're like tucked in the corners of the Z. So alternate interior angles are also the same size. They're also congruent. This one, though, and every other one after this, is a theorem. So the first one's a postulate, so we're using corresponding angles P, so corresponding angles postulate is CAP. For these guys, we say, AIA for alternate interior angle theorem, or AEA theorem, or SSIA theorem. So all the rest of them are theorems except corresponding angles. So we know that the alternate interior angles are congruent by the theorem. So if this was 100, 2 would be 100 degrees. Okay, alternate exterior, they have to be on opposite sides and both on the exterior, so 1 and I'll make this 4 would be alternate interior. Guess what? They're also congruent. So far, everybody's been congruent. Again, this is by, just like it would sound, alternate exterior angle theorem. Okay, the last two are same side, guys. So same side interior, they'd have to be on the same side of the transversal and both on the interior, so 3 and 5. So same side interior kind of make that U pattern, remember? And if the lines are parallel, remember that has to be true, then same side interior, they were not congruent, but they were supplementary. So they're equal or they add up to 180 degrees. And that's the SSIA, same side interior angles theorem. Again, everybody's a theorem except corresponding angles. That's a postulate. And then same side exterior could be like 4 and 6. They're on the same side, but they're on the exterior. And so those two angles also add up to 180. So I find the easiest way to remember is that if it starts with S for same side, it's going to be supplementary, which is 180. Everybody else is congruent. The only postulate is corresponding angles. That's the most basic one, and then everybody else is a theorem. Remember, postulates we don't prove. Theorems we can always prove, and we're going to do a little bit of that. Okay. So let's just do an example down here, a quick one. Oops. Okay, so the most basic one I could give you with this is I might give you the two parallel lines, and I would cut them by that transversal. I'm actually going to make it just a little bit less. There we go. Okay. and I might give you one of the angles. So maybe I give you this angle is 100 degrees. And I want you to find every other angle. Now remember, if they're not parallel, marked parallel, then this wouldn't be true. So we have to know that those two lines are parallel. You have to know all of that. Okay. Well, first of all, I can find every angle at this intersection just using vertical angles and linear pairs. So like this angle's vertical to 100, so it's equal. So that's 100, that was easy. And these two are linear pairs, which means they should add up to 180. And then you could do that here, or these two now are vertical, so that would also be 80. So you can get all those without having to use anything with the parallel lines. But now, if we want to make an assumption about this, we have to know they're parallel. So we do. So I would start off with, let's use the 100, and let's use this angle. So figure out what the relationship is. So 100 and this angle, they're on the same side, but one's inside and one's outside. Those are corresponding angles. And we set up at the top that corresponding angles were congruent. So we know that if that's 100, then this is 100. And then, frankly, you could fill all this in again. You don't really have to do hard work, but let's do it. Like I could use this angle 80 and this angle, which form the Z pattern. They're alternate interior equal. So that would be 80. And then I would probably just start using vertical angles from this point. So look, now you have everybody. So that's the most easiest one. Okay, so let's try another example. So check this one out. I have two lines and a transversal connecting them. They're marked parallel, so that's great. And I'm given one of them 78 degrees. So first off, I need to get all the marked angles. So measure of angle 1. Well, what's the relationship between 78 and 1? They're what type of angles? Two lines intersect, opposite angles are vertical. So by the vertical angle theorem, I know that these two angles are equal. So that would also be 78. Okay, how about angle 4? Well, angle 4 is adjacent and forms a linear pair with 78, and so that means they would add up to 180, so that would be 102. All right, angle 3. 78 and angle 3 form kind of that U pattern with the parallel lines, which makes them same side, because see how they're on the same side of this transversal here? And they're on the interior, so same side interior angles, which remember is a theorem. And what did we say? If the lines are parallel, those two angles, same side, supplementary, 180. So 78, and that would make 3, 102 as well. All right, angle 2. 78 and 2 are alternate and both on the interior, so alternate interior angle theorem would say that they're congruent. So that's also 78. All right, 5. 5 is on the same side as 78, but one's inside and one's outside. Those are corresponding angles, which is a postulate. So cap, it's the only postulate. And corresponding angles also always congruent. So that means angle 5 would also be 78. Okay? All right, so let's look at one that's a little bit more involved. So this one, they have some given information. They tell me that line M is parallel to N, so I'm going to mark that with the little arrows. And then they give me an expression for angle 4 and angle 7. Okay, so 4 and 7. So the next thing I would do is ask myself, what is the relationship between them? So where are 4 and 7 located? Where they're on the same side, but one's on the inside and one's on the outside. What type is that? Corresponding angles. So I'm going to use the corresponding angles postulate. Remember, it's the only one that's a postulate. And what do we know about corresponding angles? If the lines are parallel, they should be congruent. So I'm going to set those two angle expressions equal. That's what congruent means. So I subtract 6x. I'm going to subtract 10, and I got x equals 20. So there's x. But then they want the measure of angle 4, so I'm going to have to plug 20 back in. So I'm going to do 8 times 20 plus 10. So that gives me 170. So I would probably then put it over here, so I'm going to actually draw it. I'm going to put the 170 here. So then the next question is, what is angle 6? Well, I don't have an expression, so I'm going to have to use what I know about the relationships. So like, I'd probably first just get angle 5. So 170 and 5, these two angles form a linear pair, so they should add up to 180, which would make angle 5 10 degrees. Okay, angle 5 and angle 6 are that Z pattern, which is alternate interior angles, and alternate interiors are always congruent. So then you would know, oh, angle 6 is 10. Okay? All right. So I want to do, so that's the basics. So guys, really you just kind of have to figure out what's the relationship and what am I trying, should I be setting them equal? Or should I be adding them up to 180? Those are the two main ideas. Okay, so the next thing I want to do is I need to look at some proofs, and this will be the last thing that I do with you today. So we're going to do some proofs with these, and we'll do some more of these in class tomorrow. Okay, so in your proof, I'm going to give you that the lines are parallel. So I'm going to start you with that, and you're going to try to prove some of the theorems. So the first one I'm going to prove is an alternate interior angle theorem, because remember, any theorem should be able to be proved. Okay, so let's see. I'm going to label some things on my figure A, B, and I'll do 1, 2, actually, let me do this. I'll do 1, 2, 3. There, I like that. Okay. So you're going to prove alternate interiors, which would be 2 and 3. We're going to prove that those two things are equal. You guys already know from what we've been studying, if the lines are parallel, that should be true, but you're actually going to prove it. And these proofs are going to be on the quiz tomorrow, towards the end of class. So you do need to know how to do these. So we're going to do a couple of them, so you get to see them. And they're actually pretty easy. So we need statements, we need reasons. Okay. So first things first, let's label our figure. So let's put our givens on there. A is parallel to B. That's always the first thing we would do. Okay. So we know that they're parallel, and that's the first thing that we're going to write. We're going to write down that we're given that they're parallel. You have to. If you don't know they're parallel, you can't do anything else. Okay. The second step, the next step will always be to find a set of corresponding angles, right? So look at the diagram. Which pair of these angles are corresponding angles? Same side, one's inside, one's outside. Hope you said 1 and 3. So corresponding angles, because it's a postulate, remember postulates we don't have to prove, we know they're true. So you can always use that. If you know the lines are parallel, the next thing you should be saying should be that this angle is equal to this angle, and it's always going to be by cap. Because you don't have to prove that. You always know that's true. So once again, you start off with your parallel lines, and then you're always going to say two angles that are congruent by cap. But they have to be corresponding. You can't just pick any two you want. They actually have to work. Okay. Okay, so then you're going to pick a relationship that you already know. Like you actually already know a relationship between angles 1 and 2. Angle 1 and angle 2 are what type of angles? Vertical, that's right. So vertical angle theorem allows you to say that they would be congruent. So there you go. Okay, now we've talked about this before, guys. If you have two equations, or in this case, they're congruency statements, where these two sides are the same, what can we do with those two sides? Yep, we can say they're equal to each other. So if these are both equal to 1, then they're equal to each other, and that one is by substitution. And I'm going to use steps 2 and 3. And you did it! So guys, you just proved, you basically said these two things are congruent, so are those, and so therefore those end up being congruent as well. So you just proved the alternate interior angle theorem. You did it. Okay, let's try another one. Let's do alternate exterior angles. So we'll do kind of the same setup. I'll start with the given that the lines are parallel. I'll start with kind of a similar drawing. This time I'm going to use 1 here, 2 here, and 3 here, okay? Okay, so the first thing I would do is mark my, I guess you need to know what you're proving, right? Alternate exteriors would be 1 and 3. So I'm going to try to prove that 1 and 3 are equal. Those are alternate exterior angles. Okay, so the first thing I would do is mark my shape. So I know that these two lines, oops, I forgot to say they were A and B, are parallel. Okay. So down here, statements, reasons, always have to start with your given. So you have to tell me they're parallel. And the next thing you should be listing should be a pair of corresponding angles by cap. Your reason will be by cap. So look in this drawing. Do we have a pair of corresponding angles? Same side, one inside, outside, 1 and 2. So the next thing you can list should always be that pair of corresponding angles and you saying that they're congruent. So you would say it by cap. So it's easy. It's always like parallel lines, boom, cap. Like it's straightforward. All right, what's another relationship that you know from the diagram? Yeah, you've got a pair of vertical angles here, guys. So you're going to use the fact that you know that 2 would have to be congruent to 3 because they're vertical, which means you're going to use vertical angle theorem. You can't just say vertical angles. You have to say vertical angle theorem or VAT. Okay, so let's see. Check it out. These are both equal to 2. So I can set these two things equal to each other, or you can think of it as true substitution. I'm going to put the 1 in here. So I'm going to say that 1 and 3 are congruent. So again, I'm plugging that in. Or transitive, I suppose you could say transitive. I'm going to use the substitution for them. But I would also accept a transitive. So there you go. So we just proved alternate exterior angle theorem. All right, so let's switch it up and do one of the same side interior angles, okay? So let's try A, B, and let's do 1, 2, 3. So we're going to try to prove that these two exterior angles, so measure of angle 1 plus measure of angle 3, those two things, we're going to try to prove that they're supplementary. So we're going to prove that they add up to 180. That's our plan. This is a little bit trickier because you have to do the 180 part, but it's not bad. First things first, label that shape. Label that diagram. They're parallel. Next thing, always list your givens. Okay, what type of angles do we use after we know the lines are parallel? It's the only one that's a postulate. Yep, you look for corresponding angles. So, do I have a pair of corresponding angles? Yep. One's inside, one's outside. I can say angle 2 is congruent to angle 3. And my reason is always cap if they're corresponding. Okay. Now, the thing is, these two are equal, which is great, but that doesn't say anything about 180. So you guys need to introduce a relationship where two of the angles in my diagram add up to 180, but I have to know it. And if they're, the only other thing that I know are linear pairs. So if you're trying to let things be 180, linear pairs don't have to, you don't have to prove that. That's a property. So do you guys see a linear pair in your figure? Yep, 1 and 2. So you can say, well, I know that the measure of angle 1 plus the measure of angle 2 equals 180, which is closer. And your reason would be they're a linear pair, LPP. So now what can I do? Remember, guys, this is where I want to go. I want to be angle 1 plus 3 is 180. Right now I'm here. Hopefully you saw line 2. Line 2 says I can replace 2 with a 3. So I can say measure of angle 1 plus measure of angle 3 is 180. And that would just be substitution. Okay? So we're going to be, you are 100% going to be doing these proofs in class and on the quiz. So we'll do some more of these. This is not on the worksheet, so that's the good news. We're just going to do this tomorrow in class. I have one more that I'd like to show you. And the last one that I want to show you is, what if we don't know the lines are parallel? Okay, so we're going to go backwards. This time we're going to know things about the angles, and we're going to use that to help us prove that they're parallel. Okay, so basically, we're going to go the backwards way. We're going to say something like, maybe we know that the angles are congruent, and so therefore they have to be parallel. So we're going backwards. When you use a theorem or a postulate backwards, it's called using the converse. So you're going to hear me say things like converse of cap. converse of cap, or converse of alternate interior angle theorem. If you're trying to say, if you don't know they're parallel and you're trying to say they are because you know the angles, you have to use converse. So let me show you what that looks like in a proof, because it is slightly different. Okay, so let's say in my proof, this time I'm given, I don't know the lines are parallel, so that's not what I'm given. I'm given information about the angles. So maybe 2, 3, 1. Okay, so maybe I'm given that 2 and 3 are congruent, and I want to prove, I'm going to prove the lines are parallel. Okay, so the way that we prove lines are parallel, the bottom line is you have to show that eventually that two corresponding angles end up being equal. That's what you're going to show. And we almost always then, guys, end up using converse of cap. So let's start with what we know. What we know is that they told me 2 and 3 are congruent. So if I was doing my proof, I would start with what I know. I know angle 2 is congruent to angle 3, this time because they gave it to me, not because I got it from anywhere else. It was just straight given. Okay, do you know any other relationships in your figure? Remember, you can't use corresponding, you can't use alternate interior because we don't know they're parallel. So the only ones you can use are like vertical angles or linear pairs. Those are the only things you can use if you don't know that they're parallel. So do you guys see any vertical angles or any linear pairs? Yeah, I see a set of vertical angles. I can use vertical angles. That has nothing to do with being parallel. So I can say angle 2 is congruent to angle 1 by vertical angle theorem. So check it out. You have these two are both equal to 2, so what can we do? If these two are equal, set those two equal. So 1 is congruent to 3. And that's by substitution. And here's the really cool part. 1 and 3 are what type? Corresponding. So you just showed that the corresponding do end up being equal. So as soon as you show that, as soon as you show that that pair is congruent, you can say, hey, the lines are parallel, and it will always be by converse of cap, because you showed that those ended up being equal, which means it has to be parallel. We're going to do some more of those tomorrow. So again, just to show you, this is when you know the lines are parallel and you want to talk about angles. And this is when you're trying to prove it's parallel. So it's a little different, but we'll do a few of these together tomorrow in class, and you guys will get a good feel for how it works. Okay, so the big takeaways besides the proofs, which are good, are knowing the relationships between the figures. So guys, you have 100% have got to have these ideas down. You have to know which ones are congruent and which ones are supplementary. All right, again, if you want to fix your worksheet and turn it in again, I don't mind. You can resubmit it. That's totally fine. If you do it, just make sure you resubmit it before midnight, okay? All right, thanks, guys. I'll see you tomorrow.